Hi friends, welcome to the very first video in this playlist where I will teach the course Object-Oriented Programming 1. Throughout this course, we will use Java as a case study. If you are passionate about computer programming generally, then this is the right place for you. I hope you will stick around till the end of this series because there are lots of cool things you need to know in this domain. Trust me when I say you don't have to worry at all if you don't have any prior knowledge of programming, because I will try my best to keep it simple for your better understanding. It is also important to note that roughly 90% of the content I'll be sharing throughout this course will emerge from the course 211 material written by Professor Sahalu B. Junaid, the Dean of Physical Science and the Director of IA Abakar, both here in ABU Zaria. So for better understanding of this concept, you might want to refer yourself to his masterpiece. Don't be carried away. We are talking about computer programming. To write a computer program, one uses a computer, right? And a system is simply anything that composes of interrelated elements or components. Therefore, a computer is a system. Computer system, we call it, isn't it? Another fact is all systems have their anatomy. Hence, a computer system has an anatomy too. This is the relationship between computer programming and anatomy of computer system. And this is exactly how we get here. Anatomy of a computer system. Anatomy of a computer system means the study of the components and the internal working of a computer. But let's hold on a second and ask ourselves what a computer is. Well, a computer has infinitely many definitions, whether you call it a machine, an electronic device, or an electromechanical device. No definition is any better than another. All that matters is for any definition to be valid, it must include some keywords that precisely summarize the main functions of a computer. And those keywords are illustrated in this diagram right in front of you. We can see how a computer can accept data through the input entity, how that data can then be processed by the processing mechanisms here in the processing entity, and how then information can be stored in the memory entity or can be given out through the output entity. Pay attention to my definition. I said the computer accepts inputs and gives out information. A cool question to ask here is, why data in and information out? Well, there's a relationship between data and information, but at the same time, they are two different things. Data are raw facts that are waiting to be processed, just like a raw food waiting to be cooked. It doesn't really make sense. Information at the other end are processed data, just like a cooked spicy food, yummy and delicious. It makes a lot of sense, right? So with these explanations, we can conveniently say that a computer is an electronic device that accepts data, processes the data, and store or gives out information. Having understood what a computer is, we will now move forward to knowing its major components. A computer has two major components. We have the hardware component and we have the software component. Under the hardware components fall all those parts of the computer that we can see, touch, and play around with. They are concrete. In other words, they are physical. The software components, on the other hand, are the non-physical components. They are abstract. We cannot touch them. We can only see them through our screens as we use them or perceive their existence. These hardware components are further divided into three major subcomponents. We have the I/O devices, the memory, and the CPU. I/O is a short and conventional way of writing input and output. So I/O devices mean input and output devices. What are input devices and what are output devices? Well, input devices are those devices that a user uses to send instructions to the computer system. Example of those devices are keyboard, mouse, scanner, light pen, joystick, etc. While output devices are those devices that the computer itself uses to send response back to the user. Example of those devices are the monitor, the speaker, the printer, etc. Most I/O devices are peripherals. Peripherals are those devices we attach to our computers for better performance, like adding an external speaker to your laptop when you already have one inside of it. We will talk about the memory in a second, but let's first jump and talk about the CPU. The CPU, which stands for Central Processing Unit, is technically the brain of the computer. It is also called microprocessor or processor for shorts. Like the human brain, it does all the thinking and the decision making. It has three major units: the ALU, the registers, and the CU. The ALU stands for the arithmetic and logic units, and it does exactly as its name suggests. It does the arithmetics, that is the addition, subtraction, multiplication, and division we are used to right from our early days in school. Not only does it do the arithmetics, but also it does the logical reasoning for decisions making. The registers are short-term storage devices with absolutely limited capacity. It holds data between calculations and reasonings done by the ALU. Let's exemplify in a text editor. Suppose you press 1 plus 1 in your calculator. For sure, the answer is 2. This answer is then stored in a special type of register called the ALU, and it is denoted by AX, capital letter A and capital letter X, like this. This means the accumulator. Wherever you see this, it means the accumulator. Now, let us still assume that we need the result of the previous calculation for a subsequent one. How do we pull it? We all know that the result of the previous calculation is 2. And we know it is what stored in what the accumulator, which is a specific type of register. So how do we pull it from the accumulator for a further calculation? We simply do that by writing AX plus 2, which means whatever it is that the accumulator is holding at that time should be summed with number 2, and the answer at the end of the day will have 4. So specifically, that is how accumulator works, and generally that is the function of registers. They store data between calculations or logical reasonings. The CU means the control unit. It might seem trivial, but it is a very important unit in the CPU and in the computer as a whole. It resolves conflict by enhancing organization within the CPU and even outside the CPU with other storage devices. It is like a captain in a football field. It controls the inflow and the outflow of data in the CPU. In a simpler sentence, it feeds the ALU with data to operate on, and then it decides where the CPU should store the data it worked on. Perhaps the CPU is indeed the most committed component of the computer, because as long as the computer is on, it never rests. Now that we are done with the CPU, let's come back to the memory. Now, remember that earlier on I told you that the CPU has very small storage devices inside of it, which are the registers. And also that the computer is capable of operating on tons of data, on very much data. So if the computer can operate on much data, and at the same time the CPU has a very small storage device, how then can we use our computers to the fullest? The answer is simply the memory. The memory is a storage device with absolutely larger capacity than the entire registers inside of the CPU combined. As you can see in the hierarchy, we have two types of memory. We have the primary memory and we have the secondary memory. Well, I think we call primary memory primary because it sits closer to the CPU on the motherboard. And also, to keep things easy, we can say it communicates directly with the CPU. and that makes it more demanding, I think. There are two types of primary memory. We have the RAM, which stands for random access memory, and we have the ROM, which stands for what? Read-only memory. The RAM is called random access because the CPU can read data from it and as well write data to it. In a layman's language, we can say the CPU can fetch data from it and as well store data in it. Those continuous random read and write paved the way for the name random access memory. Hence, we can say that the CPU can access the RAM randomly. We have very many types of RAM. Example, we have the SIMM, which stands for single inline memory module. We have the DIMM, which stands for dual inline memory module. We have the SODIMM, which stands for small outlet dual inline memory module, etc. The ROM is called read-only because the CPU cannot write data to it. It can only read data from it. In a layman's language, the CPU cannot store data in the ROM. It can only fetch data from the ROM. Hence, we say the CPU reads only from the ROM, and that paves the way for the name read-only memory. One more thing to take note of is that the RAM is volatile while the ROM is non-volatile, meaning the content of the RAM escapes when power ceases from the computer, while the content of the ROM does not escape. Though we don't have it here, but there are three types of ROM. We have the PROM, which stands for programmable read-only memory, and we have the EPROM, which stands for erasable programmable read-only memory, and we have the EEPROM, which stands for electrical erasable programmable read-only memory. Talking more of it, the CPU, the primary memory, and other devices sit on the motherboard of a computer system. Earlier on, I mentioned the word motherboard, and right now I just mentioned it again. What is this motherboard? Well, a motherboard is a printed circuit board containing the principal components of a computer. To give you a metaphor, think of the spinal cord in the human body, which holds other part of the body together. That is the motherboard of the computer. It holds other components of the computer together, either directly or indirectly. We've said a lot about the primary memory, and now let's take a glimpse at the secondary memory. Secondary memory is a large capacity, non-volatile storage device from which the RAM fetches the data it serves the CPU with. It is where the computer finally stores its data and programs. But the major drawback of this secondary storage is that it is not fast. Therefore, it cannot operate in sync with the CPU. So to get around this, the RAM, which is faster and a kind of more efficient, sits between the secondary memory and the CPU. So we can conveniently say that the RAM compensates for the slowness of the secondary memory. It fetches the data that is more likely to be needed by the CPU ahead of time. So the RAM reaches into the secondary memory and fetches the data that is more likely to be needed by the CPU at a particular time, and then it feeds the CPU with that data. And when the CPU wants to store a data too, it passes the data to the RAM, and the RAM finally stores it in the secondary memory. So this phenomenon makes the entire process of read and write very fast, such that it's even hard to notice. Now that we have a deep idea of what the hardware component is all about, we will face the software component and see what it is all about. Well, we have two types of software, the system software and the application software. Looking at the computer without a system software is like looking at the human body without a soul. Without the system software, the computer will be no more than a hunk of metal. It won't function at all. The system software is the software that controls the performance of the hardware components. Under it fall three categories, namely the OS, the system support software, and the system development software. The OS stands for operating system. It provides the visible interface on which we run other types of software. It allows us to have access to the functionalities of the hardware components of our computers. Examples of OS are Windows, Linux, Mac OS, etc. Looking at the system support software, you see the OS on its own can't cover 100% effect of how a computer should effectively perform. So this category supports the OS in facilitating smooth and efficient performance of the computer system. Examples are the antivirus, the disk defragmentation, the disk formatting, etc. The last category, which is the system development software, provides services beyond those available in the OS. These services are often of more help to computer experts. One example is the language translator. Finally, the second type of software, which is the application software. These are the types of softwares that come to your mind whenever you hear the word application. They are also called client software because they are installed by the clients, that is by the users, for personal use. We have 1,000,001 examples of this type of software, few of which are the Microsoft Office, the game applications, and that video player you might be watching this video with. That is all for this video. Hope you really enjoyed it. Let me know in the comment section if you have any questions. Otherwise, let me see you in the very next one.